let's review a little bit of vocabulary before we begin. I wrote 4 words: factor, term, expression, and equation. So if you remember, this is an equation. It has 2 polynomials, 3x plus 5, and then an equal sign, and then another polynomial, 7x to the 4th plus 29x minus 11. Let's use this as an example of all 4 of these words. Okay? A factor is a part of a multiplication problem. So for example, we have 3 times x. The 3 is one factor, and the x is another factor, and together they're being multiplied. The 5 is also a factor. Okay, remember in polynomials we don't write x to the 0 power, but this is like an imaginary x to the 0 power. So remember, this is x to the 1st power, and this is x to the 0, but it's not written, because what's x to the 0? Anything to the 0 power is 1. So 5 times 1 is just 5, so we don't write that. But this is a multiplication problem. 5 is a factor, and the imaginary x to the 0 is also a factor. Okay, so 7 is a factor, and x to the 4th power is a factor. 7 times x to the 4th, so they're both factors, they're both pieces of a multiplication problem. 29 is a factor, x is a factor, negative 11 is also a factor. Remember, with an imaginary x to the 0. Okay, so this is what the word factor means. What about the word term? Okay. A term is a piece of an addition problem. So we have 3x plus 5, so the 3x is a term, and 5 is a term. We have 7x to the 4th plus 29x minus 11, so the 7x to the 4th is a term, the 29x is a term, and the negative 11 is a term. Okay, each 3 terms in one long polynomial. And now expression and equation, which is really where the important part is. So an expression is a number phrase. Okay, didn't think you would be doing grammar and math, but yes. Okay, so if you have, in grammar, you have sentences. Sentences have a subject and a verb, and sometimes a predicate noun. The subject or the predicate noun, the phrase part, would be the expression in math. So for example, 3x plus 5, that would be an expression. If we say 3 times something plus 5, is that a whole sentence? No, it's just a piece of a sentence. 3 times something plus 5, that's not a whole idea. Okay, so that's an expression. It's a phrase. 7x to the 4th plus 29x minus 11, also an expression. And then lastly, what's an equation? An equation is a whole sentence. Okay, so the is the equal sign, that's the verb, and then together it makes a whole sentence. 3 times something plus 5 is 7 times the same thing raised to the 4th power, etc., etc. It's a whole sentence. Okay, so that's what the equation is, the whole thing all together. Okay, now that we have all these pieces, let us look at 2 more terms. Okay, solve and evaluate. Solve and evaluate. So first, let's look at the word evaluate. Okay, if I say, with this is an expression. Notice there's no equal sign. Okay, x plus 7. If I say x plus 7, and then I say solve. Solve means find x. Find x. Or find the variable. Can we figure out what x is based on this? X plus 7? X plus 7. What's x? We have no idea. Okay, so we can't solve an expression. Okay, so solve is only for equations. Okay. But what does evaluate mean? Can we evaluate expressions? Yes, evaluate is for expressions. but it means plug in x. So we need to be given an extra piece of information. Okay, plug in 4x. And this is done in expressions, not in equations. Okay, this is for expressions. So the word evaluate is for expressions. And so, for example, in the directions, you might be given an extra piece of information like x equals 5. Okay, then you could evaluate, you'd plug in 5 plus 7, and you would get 12, and then you'd have your answer, put a box around it, done, right? But over here on the solve side, we don't plug in things for our variable, not the variable that you're looking for, okay? So in this case, it would be something like x plus 7, and it would have to be an equation, so it would be something like x plus 7 equals 9, so it's an equation, and then you can solve. So you would either just think about it, x has to be 2, or you could solve it the algebraic way, subtract 7 from both sides, and then you'd get x has to be 2. Okay, put a box around it. Notice that I'm putting a box around the x as well, okay, because we're solving an equation, so your answer will be an equation with an equal sign. So these are just some vocabulary words that we're going to be using throughout the year. Let's look at some problems. Some sample problems. We're going to start with number 2. The sum of 4 and x is represented by the expression blank. Okay, so we need to fill in the blank. We want the sum of 4 and x, and we want an expression. So that tells you right there, we're not going to have an equal sign in our answer. The sum, that means add. So 4 and x, sum of 4 and x. Okay, that's easy enough. And then it says 4x equal 2, the value of this expression is, so what is it asking us to do? It's asking us to evaluate this expression. It tells us that x equals 2, so we will plug that in. 4 plus 2. Okay, remember to put in parentheses in case you have negatives or something like that. Then use your order of operations to simplify your expression. All right, perfect. So 6, and let's also look at number 4. Okay, this is another one asking us to evaluate. This time we have two things. We have a 3, x equals 3, and a y equals 3. Okay, so we'll plug in 3 for both variables. 2, and then x equals 3, plus y is 3, so 3 squared, divided by 5 times 3, plus 3 times 3. Okay, so just plug in 3 in each place. Okay, and then simplify. Remember to use your order of operations. You may want to write them out just so you have them. Parentheses, exponents, multiplication and division, addition and subtraction. Okay, so first we'll do exponents and multiplication. 6 plus 9 over 15 plus 9. Okay, question, can we cancel out the 9s? Absolutely not. Okay, you can't cancel out the 9s because there's addition in the way. Remember to do your order of operations. So in this case, it's like the numerator and the denominator in parentheses. So you can't cancel until you add first. Okay, so we'll add first. So 15 over 24, and then we'll reduce to get 5 over 8, and that would be the answer. Great job. All right, let us do number 5. 5 says change the word phrase. Notice they're telling you word phrase, no verb, that means no equal sign, to an algebraic expression. Remember expression, no equal sign. Use x to represent the number. 1/5 of a number subtracted from 19. Okay, so let's break this down one step at a time. 1/5, okay, 1/5. 1/5 of a number. Of means times, so 1/5 times a number. They say to use x to represent the number, so 1/5 times x, okay, subtracted from 19. Okay, subtracted from 19. So this may not be something that pops into your head automatically. If you're not sure, you use numbers you know. So if I say 3 subtracted from 5, does that mean 3 minus 5, 3 subtracted from 5, or does it mean 5 minus 3? 3 subtracted from 5. Okay, it means definitely this one, right? So we're going to do the same thing here. If we say 1/5 of a number subtracted from 19, that means we need 19 first, and from that we're going to subtract 1/5 x. All right, great. So you'll type this in. Good job. Okay, lastly, let's do number 7. Okay, decide whether the given number is a solution to the equation. Is 1/5 a solution of x plus 7 over 9 minus 1/5 equals 29 over 35? So in this case, we have an equation that we could solve, but they're giving us a candidate solution. Okay, so 1/5. Does x equal 1/5? If x was 1/5, would the equation be true? So we're going to plug in 1/5 for x and see if the equation is still true. Okay, so it's kind of like working backwards. So we'll put in 1/5 plus 7 over 9 minus 1/5 equals 29 over 35. Okay, we're not sure if it's equal. We want to know, is it equal? That's the question. If it's equal, then 1/5 is a solution. Okay, so let's work this out. If we say 7 plus 1/5 is 7 1/5, 9 minus 1/5 is 8 4/5 equals 29 over 35. So now we need to figure out, are these two things equal? You can use proportions, you can cross multiply. I'm going to go ahead and simplify these complex fractions. So we have mixed numbers inside of another fraction. Let's go ahead and make this into a simplified fraction. So first of all, improper. So 7 times 5 is 35, plus 1 is 36, over 5 over, okay, 5 times 8 is 40, plus 4 is 44, over 5, over 35. And again, we're trying to figure out, is this equal? We don't know if it's equal, so we're just trying to figure it out. Can we simplify this even more? How do we simplify this? We have a fraction on top of another fraction. We flip the bottom one and multiply. Okay, so remember, this means divide. So how do we divide fractions? We flip the second one and we multiply. So 5 over 44. Okay, reduce this where we can. 1, reduce it 1. Erase this random line. Okay. And then reduce this. 4 goes into 36. 9 times. 4 goes into 44 11 times. And again, we want to know, is this equal to 29 over 35? So here we get 9 times 1, which is 9. On the bottom, 1 times 11, which is 11. And now that both sides are reduced completely and completely simplified, if they're not the same thing, then they're not the same. So 9 over 11 is not the same as 29 over 35. This means that when we plugged in 1/5 for x, we did not get something that was true. Okay, this is a false statement. Okay, 9 over 11 is not the same thing as 29 over 35. So because we got a false statement, 1/5 was not a solution. Not a solution.